I'm Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. Here is a very special series with my student Emmy. She has selected some excellent questions from past test papers of Edexcel. As you know, Edexcel provides a rich resource for excellent questions for high school students. In this particular video, we will look into two examples. One of them is based upon the geometric series and the other one on arithmetic series. So the first one, which is about the geometric series, here is the question for you. Now what you notice here is that the speed of the runner is constant for the first 4 kilometers and then it reduces by 5%. And 5% of the previous speed. So, in a way, the question says it takes 5% longer to cover the distance, right? As compared to the previous kilometer run. So, whenever it is based on something which is existing, in that case, it is a geometric progression. So now let us see how do we explore and figure out the solution of such question. And after that, we'll take another interesting example which will be based on arithmetic progression. Hi, Amy. How are you doing?
Hi, sir. Yeah, I'm good. Thank you. How are you?
Good. So how's your preparation for the test going on?
It's going good. Yeah. Just kind of revising certain topics that we've kind of discussed over the past few weeks. So yeah, I did have a couple questions for the arithmetic series and geometric series kind of questions, just two of them. So yeah, do you think we could go through them?
Sure. Let's see. So do you want to share those questions with me? No?
Yes.
Okay, that'll be better. Yeah.
Cool.
Sure.
I think it's
Yes, coming up.
Oh, okay. I think, can you see the screen, sir?
Yeah, very good.
Oh, okay.
Yeah. Okay.
Yeah, so question 6.
Can you please read the question?
Yeah, so a competitor is running a 20-kilometer race. She runs each of the first 4 kilometers at a steady pace of 6 minutes per kilometer.
Mm-hmm.
After the first 4, she begins to slow down.
Okay.
So in order to estimate her finishing time, the time that she will take to complete each subsequent kilometer is modeled to be 5% greater than the time she took to complete the previous kilometer. So using the model, part A show that her time to run the first 6 kilometers is estimated to be 36 minutes and 55 seconds.
Good. So that should be straightforward. We are given that, let's remember that the race is 20 kilometers, correct? This is 20-kilometer race. And she runs each first 4 kilometers at a pace of 6 minutes per kilometer. So that means, let's say, first 4 kilometers, 6 minutes. Do you see that?
Yeah.
So that is how 4 kilometers are covered. And then it says, subsequent kilometers is modeled as 5% greater. So 5% greater means what? That
times by 1.
Yeah, 0.05 times the original rate. Let me just check. What we are saying now is, first 4 kilometers, they are taking 6 minutes each, and then 5% more than the previous time, which is 6 minutes, correct? That's the whole idea. So it says, can you please read this statement once again, Amy?
Yeah. So in order to estimate her finishing time, the time that she will take to complete each subsequent kilometer is modeled to be 5% greater than the time that she took to complete the previous kilometer.
So this time, which after 6 is 5% more than 6. Do you understand?
Yeah.
So which is basically 6 times 1.05. 1
Yeah.
plus 5%. Do you see that?
Yeah.
So that is your fifth time. So then the next will be 6. This becomes your fifth time. So sixth time will be 1.05 times
Square.
1.05. Do you see that?
Mm.
So that is a series. It's kind of a geometric series thereafter. Correct? So
Oh,
you can
right.
add these 6 terms. So that makes 6 kilometers. So 6 kilometer basically will be 6 times 4, which is 24. Correct? Plus 6 times 1.05 plus 6 times 1.05 whole square. Add them up and get your answer. What do you get?
Is 6.615 had 6.3 at 4, 36.915.
So 36, we got minutes. We have to convert 0.915 into seconds. Multiply by
So
60.
times by 60.
What do you get?
54.9.
Which is rounded to 55. Is it clear to you?
Yeah.
So we're done this, correct? So that is how you're going to do part A. Now, can we look into part B?
Yeah. So show that her estimated time in minutes to run the R kilometer for where R is in between 5 and 20, both included, is 6 times 1.05 to the power of R minus 4.
Correct. So now let's look into this sequence which we have. So we have first term, right? Second term, third term, fourth term, correct? Now, after that, subsequent terms are time is increasing. She's tired, right? So 6.6 times 1.05, and then 6 times 1.05 whole square, and then 6 times 1.05 cube, and so on. Do you see that? So
Yeah.
that becomes your sequence. So this is your first term, second term, third term, fourth term, fifth term, sixth term, seventh term. What do you observe? For the nth term, what should be the time taken? That is what we have to see, right?
Yeah.
So obviously, it has to be 6 to begin with. But within the bracket, we are not very sure what should be the power, correct?
Yeah.
Should it be n, n minus 1, n minus 2, or what? Now you will see that the exponent is 1 when it is 5, 4 less. Do you see that? Exponent is 2 for the sixth term, correct?
Yeah.
4 less. Exponent is 3 for seventh term. That is 4 less than the term number, right? So if it is nth term, so it has to be n minus 4. You get the idea.
So to show that, can we just do what you did and then say 5 minus 1 is 4, 6 minus 2 is 4? Is that what they're looking for?
Or you can say, actually, it is a geometric series starting from here, right? Do you see that?
From 6 times.
Taking 6 as, so 3 are fixed, correct?
Yeah.
Then 6 is your first term, correct? And then every other term is multiplied by R, which is 1.05. And then you can use the geometric series, and obviously you got those. Generally, the formula is n minus 1. But since it is the fourth term, 3 more terms, n minus 4. It makes sense. You can do like that also.
Because I was trying to use the formulas, the AR to the power of n minus 1. So I'll just substitute A as 6, R is 1.05.
Yeah, but after the fourth term, right? Yeah,
after the fourth term. So then you can't put 4 minus 1 as the power, like using the formula.
No.
Yeah, no. Okay.
So this is a simple way, which I have shown you. You can relate that the term number and the exponent, there's a difference of 4. And therefore, for the rth term, what will be the result? For the rth term, the result will be 6 times 1.05 to the power of n is r, right? So r minus 4. Is that clear to you?
Oh, okay. Yeah.
That's clear. Part C.
So part C is estimate the total time in minutes and seconds that she will take to complete the race.
Correct. So race, remember, it's 20 kilometers, correct? So what we can do now is, we can now use the geometric series formula.
Formula.
Formula. So we have fixed 6 times 3 is fixed, 18, right? That is 18 minutes in all, correct?
Yeah.
This is first 3 kilometers. Let me write down. This will be first 3 kilometers, right? Will take 6 each. Then from the fourth to how many? 70.
6. Oh,
20, right? Total?
yeah.
Total is 20, correct? So fourth term will be. So we have added 3 already. Now we have to go to the fourth term and thereafter to 20th. So 20th term will be 17, correct?
Yeah.
So you can use the formula now, thinking this is your term number 1. So let's say another series is 6 and then 6, 1.05 and then so on, right? Where A is 6, R is 1.05 and the number of terms N is 17.
Yeah.
Use your formula. What is S of 17 equals to? A times.
So is it 17 or is it like 14? Because it's only between 4 and 17.
Yeah, but 17, no, 20 kilometers you have to run total, right?
Yeah, but you know when you use the formula, are we putting it N as 17? Because we've already done 6 times 3.
Yeah, 6 times 3 is the first 3 kilometers. Now 17 left. 17 terms left. So we are adding first 18 minutes to the rest 17, which will follow a geometric series pattern.
Okay.
Constant, correct?
Yeah.
So A times R to the power of 17
and minus 1
over R minus 1. Calculate this.
Okay, so 6 times 1.05 to the power of 17 minus 1 over 1.05 minus 1.
What do you get?
155.042.
Okay, so
how many?
you have to add 18 minutes to this, correct?
Yeah.
So how much you get?
173.04.
And 04 multiplied by 60? So 173 minutes. And 4 times 60, 24 seconds.
Yeah, 0.04 times 60 is 2.5.
Oh, it was 0.04. Okay.
No, it was like you wrote it. It's 173.04. So don't you do 0.04?
Okay. Yeah, you multiply by 60. How many minutes? Seconds.
2.5.
Okay, so write 3 seconds. Round down. So that is how you're going to do it. Is that clear to you?
Oh, yeah. So yeah, I got a bit stumbled at part B. Yeah, which was only 1 mark, but I don't know. I was just trying to get the concept. And, because of the first 3, I was just finding it hard to see a pattern and stuff. But yeah, when you wrote it like that, it was pretty clear. So yeah.
Great. So this is clear.
It's clear.
Can we take the next question?
Yep. It's kind of on a different document.
No problem.
Okay.
You can share with me those documents, right?
Yes, I will do.
Yeah.
Don't know if my internet is being quite slow. It's good.
Many people are using internet now, right? So the lines are not really equipped for that.
Yeah.
Long question, yeah.
Kind of long, yeah. Okay, so question 9a. Calculate the sum of all even numbers from 2 to 100 inclusive.
Okay.
So yeah, I just used a formula.
So yeah, take 2 common.
And then do 1, 2, 3.
So 1 plus 2 plus 3. Last number will be 100 over 2, which is 50, correct? Now you have sum of natural numbers. Sum of natural numbers is what?
N times n plus 1 over 2.
Perfect. So number of terms here are 50. Do you see that?
Yeah.
So let me write this as 2 times. So this series sum will be 2 times n is 100 by 2 is 50 in this case, right? Plus 51 over 2, right? n times n plus 1 by 2. So 2 and 2 cancel. And you can write down now, what do you get? 50 times 51.
Oh,
Correct?
you did it like that.
Yeah.
Yeah. No, so I did 50 times 51 over 2, and I got 1275, and then I times it by 2. Oh yeah, I got 2550.
Same one. Doesn't matter. Okay.
Oh, okay.
Next part, please.
So part B is in the arithmetic series, k is a positive integer and k is a factor of 100.
Okay. So they will go evenly, no fractions. Correct. That's what they mean.
Okay.
Right?
Yeah.
So again, let's take k common. So you get what? 1 plus 2 plus 3 plus 100 over k. Do you see that?
Yeah.
So it is very similar to the previous one, except for now you don't know what 100 over k is, correct?
Yeah.
But you can apply the same formula. So we say now S with these k series will be what? So 2 times the first term, there are how many terms? 100 over k terms, right?
Wait, so are we doing part I or you're just doing?
Okay, what is part I for you?
Find in terms of k an expression for the number of terms in this series.
Oh, number of terms. So number of terms will be 1, 2, 3, and last will be 100 over k. Do you see that? Like in the first one, 50. So number of terms will be 100 over k. Is it okay?
Oh, yeah.
Correct. Those are the number of terms. Now part B. So we did this. Part B is?
So part B is show that the sum of the series is 50 plus 5,000 over k.
I was doing part B directly. Okay, so that's funny. So we know that the number of terms are 100 over k, correct?
Yeah.
Applying the formula. So first term, 100 over k number of terms, then 100 over k plus 1.
Plus
correct?
1. Yeah.
And everything divided by 2, right? So this 2 and 2 cancel, correct?
Wait, so how did you know it was 2 on the outside?
Yeah, that is the formula, right? Sum of series. You said this is your formula, correct? Sum of n numbers.
2 over.
Yeah, because these are n numbers, right? Natural numbers. 1, 2, 3, 100 over.
Yeah, but you wrote 2 times 100 over k.
Yeah, because I see, I'm rewriting. I'm writing the formula is 2 times n plus 1. Why did I write 2 times? Oh, sorry, k times. I'm so sorry.
Oh, yeah.
So sorry. I got mixed up. This is the formula, right? Sorry.
Yeah.
You are right. So in this particular series, k is outside, not 2. Last time 2 was outside.
Yeah.
K will be, k times. K times 100 over k. They are number of terms times
100 over k plus
100 over k plus 1 divided
over 2.
Yeah, that is it. Correct. So let's expand this. So that gives you as when you do this 100 over k. Yeah, first.
That's really gross.
Let me just cancel first, and then we can cancel at least 1k. Correct. And then we can cancel these two also.
50
so we
and
get 50 times 100 over k plus 1. Is that clear to you? So 50 times
so that's where they get the 5,000.
Over k plus 50, right? So that's what we have, right? Rearrange. Good. So that's how you get your standard formula as given here. It's a very useful formula, I mean. So if there are like products as shown here, you could always, now you understand how to derive it.
See, it's only when I came on with you, sir, I just remembered the sum of natural numbers formula. When I was doing it myself, I was stumped. I was like, oh my God, how am I supposed to do this? Because like from k to 2k, you're adding k, right?
Yes.
And so I was going to do this whole let like the difference D be K, and it got really hectic. So all I need to do is take out, only remembered it.
You come out with amazing methods, Amy.
So they're not all good ones, but I do try. Okay. Yeah, I feel like everything, suddenly all the ways to answer the question comes when I'm with you on this.
Good. Okay, what is part C?
So part C, find in terms of K the 50th term of the arithmetic sequence.
Okay, so that should not be difficult. So you got, let me rewrite here, 2K plus 1.
2K plus 3
and
is D.
4K plus 4. And then 6K, 6K plus 7. Do you see a pattern?
2K plus 3?
1.
Adding?
This is your first term, second term, third term, right? So find in terms of K, the 50th term. So first term, second term, third term. So they are getting multiplied by 2. Do you see that first number is getting times 2? If you see this number, it is times 2. Is it okay?
Yeah.
So we can write this term number as, let's say we have Tn. Then in that case, that n times, right? 2n, 2 times nk. Is that okay?
Yeah.
Now, what happens with the next number, which is 147? So how that?
Plus 3.
Plus 3, right? So it is going up by 3, right? So what is 3 times 2?
6.
How do you get 4? Minus 2. 3 times 2 is 6. And how do you get 4? Minus 2, right? So I'll tell you again. What is 3 times 2? It is going up by 3, right? So the factor of 3 can help us figuring this out. What is 3 times 3?
9.
And minus 2 is?
7. Oh, so you're saying do 3n minus
2.
2. Oh, yeah.
Because it went up by 3 each time. That's like a slope. You see that?
Yeah.
A fixed number.
It's like the nth term concept when we used to do
nth term
it.
concept.
Oh,
so you have to multiply by m, which is 3. So 3 times 3 is 9. But I want 7. How do I get 7? Well, take away 2, you get 7. And that's how you get your formula. So we get our formula for Tn, and we are saying that the nth term is going to be twice nk plus 3n minus 2. Is that okay?
Yeah.
So we're done this form, giving your answer in the simplest form. Okay. So I think this is simple enough, right? Yeah. So that is the simplest form. That is how we are going to answer this particular question. Does it make sense?
But I think they're asking for the 50th term. So do we just sub in 50?
Oh, I see it. Right. It's just sub 50. Yeah. Okay, good. You are keeping track of the question.
No worries.
No wonder you have a test
100K. Yes, so I need to get in a mindset.
Yeah, so it will be 100K.
Yeah, plus 148.
Plus 150. Oh, that is why. Okay. So 100K plus 148. Okay. So that becomes the simplest form. Done. 50th.
Cool. Yeah.
Good job. So I think this concept is clear to you, right?
Yes, very.
Very beautiful question. Simple but thoughtful.
Nice. Yeah.
So can you summarize our learning on the 2 questions which we have done just now?
Yeah. So this one was the key formula to use is the sum of natural numbers, because in both part A and B, you can take out a common factor. So in the first one, it was 2, and then we can just do 1 to 50, add it on. And then in part B, it was taking out K and then going up to 1 to 100 over K. So yeah, using that formula is super important. And then when we got to part, like on the other part, it was trying to show the sum of the series. So we just used the formula and simplified our equations. And then part C was kind of using like the nth term rule in terms of what is it going up in. And like when we saw there's a pattern of 3, how do we get to 1, and like 4 and 7, we just had to subtract 2. So that's how we got that value. Then once we got our tnth kind of formula that we kind of derived, we just subbed in the 50 because that's what they're asking for, and then we got our value in the simplest form.
Perfect. So the two examples, one involved arithmetic series, the other involved geometric series, and the combination of these two. So I think that's a very good example. So we'll end our session here, Emmy, today. I hope you understood the whole concept. Thanks.
Yes.
I hope you understand and appreciate the solution of these two questions in the video. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.